For the better part of a decade, I would occasionally attempt, and fail, to see or photograph rare phenomenon above thunderstorms called sprites. But all of that's changed now. The number of sprite photographers are few, and explainers on the internet on how to actually go about it are a little bit too simplistic. The information available online is just too ambiguous, or it hasn't actually translated to a successful sprite encounter for myself and many others. I've had an interest in sprites since the late 1990s, where as a teenager, I stumbled upon them while studying weather on the fledgling internet in my spare time, like kids do. Later, I had to learn how to see sprites for myself. After analyzing others' successes and my own trial and error for years, almost suddenly, I started to be able to capture and see them almost every time I attempted to. This is Michael, the sky-watching obsessed outdoor content creator, science out there. Let me be right up front with you. I'm relatively new to success with capturing sprites, but as a longtime storm chaser, astro, lightning, and aurora photographer, I find that I'm uniquely positioned to help fill a gap and also help all of us expand the body of knowledge for this relatively young and niche hobby, one where new discoveries are happening right now. I might do this whole video again in the future with everything new that I've learned and encountered since posting this one. Things are moving quite fast in this field of study. In order to see sprites, you need to know 3 things. What type of storms produce sprites, where to be to see those sprites, and how to watch. To capture them, you need to know 2 more things. What photography equipment to use, and what techniques to use. But first, we need to briefly take a second to understand our target and why this can be so difficult. Sprites occur high above thunderstorm complexes at the same time as some massive lightning discharges near the ground. The most well-behaved storms will produce events that occur 2 to 3 minutes apart. Sprites and the related events like jets, elves, ghosts, and pixies all occur between about 12 kilometers above ground, or right at the tops of thunderstorm anvils, up to about 90 kilometers, literally the edge of the definition of space. And finally, and I think most importantly, the most common form of TLE, the red sprite, itself produces the majority of its light at and just beyond the red part of the visible spectrum. In other words, they are very red. In fact, redder than red. Or exist in an area of the light spectrum from the deepest reds to the area called near infrared. I'm telling you this for 2 reasons. Certain kinds of color blindness may cause you to see them as white or yellow instead, and potentially not visible at all, while digital cameras, even very obsolete ones, can actually be modified to take full advantage of the parts of the light spectrum where sprites are brightest. Jellyfish sprites, their tendrils and associated jets are sometimes naked eye visible, but for a very short time, while other events like elves and ghosts are usually not naked eye visible. These events are short-lived and most often faint. However, when you do see a big event, it's breathtaking. You don't get a chance to really soak in what you just saw. And once you've seen a few, you'll get very comfortable spotting them. For the best experience, and of course to share your experience, I recommend aspiring to photograph them as well. Certain kinds of thunderstorms and their environments are better at setting up the conditions that can lead to sprites. And to be honest, there isn't exactly 100% concrete evidence on whether one kind of storm or another may produce them, or what sort of atmospheric parameter space should lead to them. But there are lots of clues and also shortcuts that can help us skip over those details for now. Meanwhile, I've made it a mission to document as many sprite-producing or non-sprite-producing storms as possible. I want to narrow down the answer to this question. The first shortcut is look for major severe weather events that might occur overnight on especially moonless nights where you live. The best places and times for capturing sprites are in the middle latitudes during your local spring and summer, and also the tropics when it is your local rainy or tropical storm season. The main point here is that sprites are accessible to see and photograph for almost anyone save for the very high latitudes close to the poles, where overnight severe thunderstorms are way more rare. In the populated middle latitudes, the best kind of thunderstorm to look for is something called an MCS, or mesoscale convective system. It has other names, like its most powerful cousin, derechos. But simple line storms, bow echoes, or squall lines are all types of MCSs. Various clustered complexes of storms, typically oriented north to south, or forming a backwards C-shaped arch. In my own experience, these are far more productive at producing sprites than supercell or multicell thunderstorms, which can also produce them, but less often. Here's the big difference. Lone, isolated supercell thunderstorms are just one updraft, while MCSs contain many of them. while weak multicellular or popcorn-style storms that form and quickly die don't offer much of a chance to be in the right place. And for sprites, that can mean the difference between infrequent and weak sprites versus many, large, complex, and bright sprites. So if you have many overshooting updrafts to observe simultaneously and in the same general direction, your chances of catching sprites increase dramatically. In various weather models, when looking for sprites, I want to see two things: a large complex of storms and a clear area well away from them where I can see over the top of a thunderstorm. When a powerful thunderstorm updraft hits the upper troposphere, it reaches a temperature equilibrium and cannot travel any further up. Updrafts can sometimes have enough momentum to punch further, called an overshooting top. However, it will still lose that upward speed, slow down, and then the leftover of that cloud is pushed and stretched across the upper troposphere and can extend for hundreds or even thousands of miles. The resulting shape resembles that of a blacksmith's anvil: a base with a bell shape at the bottom, a portion that is back sheared, and a part that is sent downstream in upper level winds. These overshooting tops and anvil areas are also the coldest part of a storm when observed via infrared by satellite, though these products typically show you cold parts as deep reds, yellows, and blacks. Forecast models can be viewed on many platforms and sites, but the one I'm going to use for forecasting is Pivotal Weather. Two fairly reliable convection-allowing models for the United States are the HRR and the 3-kilometer NAM. The product of those models to use is simulated infrared satellite. Outside of the United States, you'll have to find a local system that works best for you that provides a similar experience. Models provide an advantage, but aren't gospel. For real-time cloud cover at night, look at infrared satellite images to find the best position to be in when the time comes. What I'm looking for on models are large complexes of storms that are still going strong after sunset or overnight, where there are very cold dark yellow and slate gray tops, and where there are potentially clear areas away from the storm with a clear view over the top of that storm. In the spring and summer, 0Z, or midnight Greenwich, England time, is about 2 to 3 hours before sunset in the eastern United States, while in Europe, you'll want to look at about 21Z and later. Use an online time zone calculator, or just get used to calculating in your head what time night begins for your location. Like for me, 0Z minus 6, 1800 hours, or 6 p.m. And 06Z minus 6 is my local midnight. Now, many guides online will say that you want to be about 80 kilometers or 50 miles, or perhaps 100 miles away from a storm's core to observe sprites. This is an okay rule of thumb, but a more important way of thinking about this is that you need to be in a place where the anvil top of the thunderstorm is not above you or nearby and blocking your view of sprites. You may only need to be 20 or 30 miles from the edge of the anvils and still see sprites. Yet you might be 80 miles or more from the storm's core, as presented on radar, where the sprites are coming from. Storm anvils spread in the direction of upper-level winds, and that might mean if you are in the wrong place, you could be hundreds of miles from a storm, but still well under the anvil clouds if you are downwind from that storm. Real-world scenarios often introduce challenges, like clouds where you weren't expecting them. Broadly speaking, it sounds simple enough until you experience these unexpected problems for yourself. In the northern hemisphere and in the middle latitudes in summer and spring, the bulk of storms' anvils will blow away in the prevailing upper-level winds to the east, and most commonly to the northeast. Meanwhile, backshearing, or the backside of the storm complex, is normally a much shorter part of the anvil. So with that in mind, in the northern hemisphere, you will normally want to be northwest, southwest, south, or southeast of an MCS for the best chance to get a view of sprites, with south and southwest being potentially the best place. In the middle latitudes of the southern hemisphere, this is mirrored, with locations to the southwest, northwest, north, or northeast typically being the best place to locate sprites. And don't be afraid to look for sprites over storms that are over open water. I haven't tested this myself, but storms over the Mediterranean, for example, can be really good at producing sprites. Supercharged bolts that are coincident with sprites and other TLEs seem to be especially common over open water. I've photographed sprites from 40 miles away and 230 miles away. It's all possible. You just need to be far enough away from the anvils, with clear skies overhead and all the way to the storm complex. Far enough away to see over the top of the storm, and that's it. Now let's talk about how to watch for them. While some bigger Sprite events are naked eye visible, you'll want to set up the right conditions to make the most of these fleeting milliseconds. And to do that, you need to avoid two major problems: bright moonlight and light pollution. To avoid light pollution, choose a location to observe from that's way out in the countryside. The darker the location, the better. Use sites like Dark Sky Finder to match up locations you've forecasted already that you might see sprites from, to locations that are also dark. Next, check the lunar calendar, moonset and moonrise times. If the moon is up while you are attempting to watch for sprites, your experience will be severely degraded, or it might be impossible to see them altogether. Later, I'll talk about photographing them and how it's possible to overcome these two hurdles a little bit using cameras. But even then, it's much preferred that you avoid moonlight. The days immediately around a bright full moon are pretty much a no-go, while the days near a new moon will allow you to use an entire night to see sprites. Another problem is that you need a clean view of the horizon. Preferably there's no major cities in the direction of the storm you intend to photograph either. But importantly, you need to be away from trees and objects that could block your view. Put yourself at the edge of an open field or a body of water between you and the direction of the storm. And I can't emphasize enough, you want zero obstructions. Depending on your distance, sprites may only be 10 or 15 degrees above the horizon. And if it isn't already obvious, you are very likely going to have to drive somewhere to see sprites. Storm chasers are uniquely blessed in that they are already spending the day following powerful storms, and need only spend an hour or two driving to a dark location far enough away as the sun sets. Astrophotographers will also have a head start because you probably already have a list of dark locations with views nearly down to the horizon, and are probably already well aware of the lunar cycle without even having to check, but are also familiar with stars and constellations. I'll tell you why that last one is really helpful in a bit. Lastly, the storm itself may be producing a lot of lightning. This won't necessarily prevent you from seeing sprites, but if you have a way to block the lightning somehow, that'll help. You could just use your arm, but you'll probably get pretty tired of that really quickly. Be patient. Some storms will produce dozens of sprites per hour, while another storm might not produce any sprites for an hour or more. Consider that you'll be outside in the dark, staring aimlessly at the back of a storm for a few hours. It's probably going to be windy too. You are, after all, out in the open, near a storm complex, experiencing some downstream effects of that weather. Bring some creature comforts: a lawn chair, beverages, a light jacket, a hat, bug spray, a podcast, or maybe even a radio. Avoid ruining your dark adaptation. Stargazers are familiar with this practice already, but in case you aren't, avoid white flashlights and instead bring a dull red light, and only use it when you have to. Shut all the lights off on your vehicle and get away from busy roads with bright headlights, interrupting the experience. Don't stare at a cell phone or other LCD screens between watching sprites if you can avoid it. Here's a simulation of what you might see watching for sprites. You'll often see huge surges in brightness coming from the storm below, and some pale white flashes above the storm that seem to linger just a slight bit longer than that initial bright flash. For bigger events, you might see a gigantic red apparition, and you'll know it when you see it. It's hard to describe it or simulate it, but when you do for the first time, your jaw is probably going to drop. Astrophotographers already know how to focus a camera at night. If you've had practice photographing lightning at night, aurora, or meteors, you'll already be well on your way. So while sprites are relatively rare or just harder to catch, there's plenty of things to practice with while you wait for your chance to try. Storm chasers are also uniquely well suited to sprite photography because they are often already in the right general area, and many have already practiced lightning photography. So picking up any of these side hobbies can go a long way to preparing you beyond what I'm about to tell you. Now that you know where to be and how to see sprites, it's time to set up your camera. What kind of camera should you use? What settings? And what techniques work best? To photograph or record sprites consistently, you need to satisfy two conditions. Can your camera be set to ISO 3200 or 6400 and still produce somewhat clean images? And is the lens of that camera capable of f2 or lower? Also, can you take photos or record frames consecutively without any gaps in the recording frames or images? Or for example, if you are recording a video at 24 frames per second, you need the shutter speed to be 1/24th of a second. Some cameras won't do this, and instead you'll need to record at 30 FPS and 1/30th of a second, or 25 FPS and 1/25th. Millisecond gaps in your recording could easily miss sprites. Do not forget your tripod, and don't even bother trying without one. For still photographs, you can take long exposures, but you'll also need an intervalometer. If you take 10-second long images, you need to take photos at 10-second intervals. The length of your long exposures will be limited by the darkness of your surroundings. Sprites will simply paint themselves onto your image. But in the meantime, every bit of stray light and sky brightness is going to slowly, or even quickly, wash your photo right out. You want the sky to remain pretty much black down to the horizon, so adjust downward from 10 seconds until it is. If you are down to 2 seconds or 1 second per image, you are either in too much light pollution or in some moonlight, and maybe it makes more sense to switch to trying video instead. It's important to note that the shutter speed of your still photos or the frames per second of your video isn't that relevant, so long as it matches your frame rate. Sprites will fully expose quite nicely at ISO 3200 and about f2. Instead, you are managing all of the other light sources that might interfere and avoiding gaps in your recording where sprites might sneak in between. Okay, let's get more specific here. I have a number of cameras that I've used already to capture sprites. I have a Canon 6D Mark II, for example. This is a full-frame camera and considered to be a middle-of-the-road DSLR, and it's been on the market for probably 5 years. It takes wonderful pictures of sprites when paired up with a variety of different lenses. Between ISO 3200 and 6400, it takes fairly clean images at night. The point is that most middle-of-the-road DSLRs are just good enough to produce some wall hangers. Now, what kind of lens do you choose from here? A 20mm f1.4 lens feels a bit too wide. Sprites will occupy little of the frame and lack some detail. There's just a lot of wasted space, pun intended. At the other extreme, I have a 135mm f2, and I usually stop this one down to about 2.4 and have to compensate with even higher ISO settings. This gets really tight, highly detailed images of sprites, but it's a little too tight. I often miss sprites to one side or the other, or fail to capture a whole sprite event because I'm pointed too high or too low. And there's usually no other context to the image. At 85mm, it is still most of the time too tight and still provides no other context to the shot. But the sprite detail is beautiful at this focal length, and I miss fewer sprites with it. At 50mm, I can capture an entire sprite and have some context too, at the cost of some detail and structure of the sprites. The only problem is I just got this lens at the end of the season, and I've only had one opportunity to try it, and it was with a finicky storm. And while I don't own a fast 35mm prime lens yet, this is probably the optimal lens for capturing mini sprites and other TLEs. Unfortunately, fast prime lenses tend to be a little bit on the expensive side, but for Canon owners specifically, a 50mm 1.8 can be had for well under $200, or about $400 for this 50mm f1.4. Fast 50mm lenses are some of the cheapest lenses there are, and it just so happens to be great for sprites. Be aware though, it behaves a bit more like an 80mm lens on cheaper crop sensor DSLR cameras, which isn't exactly a bad thing once you get a handle on this. In fact, let's look at the more budget end. I've also captured sprites with a modified Canon T3i. I did a video about that modification years ago and even mentioned sprites being a reason why I did it. Full spectrum modification cameras can capture sprites at much lower ISO settings. Remember, the sprite itself is actually brightest just beyond human vision and the sensitivity of most stock cameras. I've gotten lots of sprite captures by combining an f2 lens and using ISO 3200 on this camera. It's an older camera and pretty noisy, which is going to cost some detail. But a camera like this might only set you back a couple $100 used. A T3i costs almost nothing to and minimal effort to modify, and works very well when paired up with a fast 35mm lens. I haven't tried it yet, but even the cheapy kit lens and ISO 3200 or 6400 with this modification might be enough, as sprites are just so much brighter to these modified cameras. At the prosumer and enthusiast level, I also have a Sony a7S III. This camera can capture sprites in high-speed video in S&Q mode, and can do so with a high level of detail and in spite of horrible light-polluted situations, like this capture, and also this one, in spite of a nearly full moon. So what about the most common cameras out there? Well, in theory, you can do ISO 3200 and f2, give or take, on an iPhone, some point and shoot, or GoPro and other action cameras, and so on. The problem is these cameras are usually really noisy, or the focal length is much too wide, and the in-camera compression and noise reduction will just eat a sprite right out of existence. But it still might be possible. I have tried this, but with no success. I don't think it's impossible, however. GoPros have a night-lapse raw image mode that should be able to pull it off, at least in theory. Using third-party camera software on your cell phone might allow you to bypass some of the standard compression and noise reduction problems inherent in the stock camera apps. Plus, both action cameras and cell phone cameras are always improving at low-light photography with every generation. Unfortunately, they are still about a full decade or more behind DSLR and mirrorless cameras when it comes to low-light performance. So let's not leave any holes here. I'm going to walk you through every step. Set your camera to manual mode, ISO 3200 or 6400. Set the f-stop to 2 or lower. Try 10-second exposure length to start and adjust up or down depending on how quickly the sky is washing out of your test shots. Make sure you are shooting RAW or RAW plus JPEG. JPEG doesn't store enough color fidelity and might crunch sprite details away. Switch to manual focus as well. Point your camera at the brightest star you can find and adjust the focus so that the star is as small as possible. If your camera has an on-screen digital focus zoom, use that and adjust the focus again, making the star as small as possible. Better yet, pan around and look for a dimmer star and adjust focus again. Focus is extremely critical. There are fancier ways to do this, but this will work well enough under most circumstances. Just avoid autofocus altogether. Point the camera so that it is centered just above the storm. Use the internal intervalometer function or an external remote to begin capturing images. If you are taking 10-second images, set the intervalometer to 10 seconds as well. You want 5 every 5, or 10 every 10, 15 every 15, etc. Take a few test shots, and again make sure things are in focus. Also make sure the sky just above the storm doesn't just flood out to bright white or yellow. Drop your exposure time and interval until the sky comes out adequately dark. Watch visually for sprites while your camera is taking photos. Let the photo session run for about 10 minutes or so at a time. Then review your images. If you see some sprites in your image sequence, awesome. You've joined a tiny club of people out there that have managed to capture one. Adjust your camera's position to take best advantage of where sprites are occurring and start again. One advanced technique that you can do works something like this. If you have 2 cameras and or 2 different lenses, this works wonderfully. Throw a wide angle lens on one of them and a narrower angle lens like a 85 or 50 millimeter on the other. Use your wide setup as a bit of a sprite scout. It may be hard to predict at first where the sprites are and if they are even happening at all. Locate the nearby stars or constellations that sprites are occurring next to. See, I told you astronomy enthusiasts and astrophotographers will appreciate this. Then point your narrow angle lens and camera at those stars. Sprites will usually cluster around the same general area of a storm for 30 minutes or a few hours, but your storms are constantly moving, evolving, and perhaps strengthening or dissipating. So your scout camera can keep you informed on where to point your other camera for the best possible shots. A question you might be asking is, why don't I just use a really high ISO setting? My camera goes all the way to ISO 100,000 and then just use an f2.8 or even an f3.5 lens. The answer is yes, you can. However, ISO for the most part is only boosting the sensitivity of the sensor, and there will be more noise, and stray light will wash out your image too fast if you're doing stills. You can't exactly cheat at light. You want to collect more photons, not just boost the response to a handful that gets squeezed through to make it to your sensor. So while you can, in theory, use higher ISO and slower lenses, your results will generally be worse. Though in the future, camera sensors will likely continue to get better. You can get expensive low noise, low light specialty cameras to get around this, but you'll spend far and away more on that camera than you would have on a good lens for the DSLR already in your bag. And if you already have an expensive, wonderful low light camera, why put a cheapy kit lens on it? So let's review and tie this all together. Look for large overnight thunderstorm complexes in the forecast. Estimate where you should be relative to the storms using simulated IR on the NAM3K or HER models, or your national equivalent if possible. But remember, they are just models and models get things wrong, so be willing to adapt. Find clear skies about 30 to 150 miles away from the edge of the anvil tops of these storms. Pair that up with a location that is far away from intense light pollution. To be specific, look for Bortle 4 and lower areas if possible. Find a clean view of the horizon in the direction of the storm. If you can see some frequent lightning-illuminated storm clouds right on the horizon and stars are visible above it, you are probably in just about the right place. use a DSLR camera on a tripod with some sort of intervalometer. ISO 3200 and f2 short focal length lenses. For stills, try 10-second exposures and adjust up or down depending on the outcome, or try video. Make sure whatever you do, your frame rate or shooting interval matches your exposure time. Focus, focus, focus. And finally, if you catch your first Sprite or your technique improved thanks to this video, please share on Twitter and tag me. Ask me any questions in the comments and I'll be happy to help. I'll revisit this topic in the future to either expand on this video or make an even better one to replace it or update it if need be. Your questions and your experiences will go a long way helping with that. There's a Discord link in the description and on the pinned comment. Why not join in and have a whole conversation with us about sprites if you want? Meanwhile, I'm just going to work on getting even better at this and collecting more data. I'll also practice some new ideas and techniques, and even stretch the boundaries for what kind of gear we can use to capture sprites. Check out all the unique content on my channel page: storm chasing, astrophotography, space weather, outdoor adventure, and more. Subscribe if any of that sounds like something you'd like to see more of from me. Until the next one, I'll see you out there.